Welcome back friends, and today we are going to discuss about one of the design patterns, which is chain of responsibility pattern, and we will see some C++ code as well for that pattern. It's a simple pattern, so let's see that when we use it and what is the use of in which situation we can use it, and what is this, and what is the class diagram for this. So let's start with the basic definition of chain of responsibility. When we use it, we use when we have interdependent modules and each of those modules perform a specific task or a part of some task. Suppose we have a system and in that system there are number of modules. One module performs certain task, the other module performs certain task, and similarly rest of the modules are performing some other tasks. But each of these tasks, when they are combined together, they perform one single task in entirety, right? So complete one single task, we need to take help from each of the modules, because some part has been performed by one module and some part has been performed by some other module. And it may be that someone has requested some kind of task which is performed by a specific module, and there is a need of going through all the tasks, or you can say the modules for that particular request. It may be that a particular request passes through a number of modules, and whichever module is able to handle the request, that will pick it and that will process the request and return the result. So in these two situations, chain of responsibility pattern is used, and I will show you in example that how we can use it with an example of an ATM machine, right? So here you can see whatever has been written. I have already explained it to you. So let's move to the class diagram. So this is the class diagram for the chain of responsibility pattern. You can see that this is the client which is using the handler. This is the symbol of using. Client uses this handler, and you can see that this handler is the main class. This is the base class, and there are two derived classes which has been derived from the handler. One is concrete handler 1 and the other one is concrete handler 2. Similarly, we can have number of handlers, handler 3, handler 4, and those handlers are nothing but the modules. They are just the modules of the system which will perform certain task or the part of some task, right? So we have concrete handler 1, 2, and you can see that concrete handler 2, it has been shown that concrete handler 2 is having a successor, which is again a new handler, right? So this is the way we will create a chain. Each handler will contain a successor, right? So this is the simplest class diagram for any of the design patterns I have ever encountered. So this is the simplest design pattern, I think, and it has a very simple class diagram. And we can see one example like how we can use it. You might have visited the ATM, and in ATM you might have seen that there are 100 rupees bills, there are 1000 bills, and there are 500 rupee bill, right? So if someone places a request, then there are different slots in the ATM machine, and if you have placed a request for 1000 rupees, then it will search for different slots. Like first it will go through the 500 rupee slot, and then it will go to the 100 rupee slot, and then it will move till it finds the correct slot, that is the 1000 rupee slot, or whatever amount of money you want to dispense, you want your ATM to dispense, right? So that way we can that is an example of a system, how we can create it, right? How we can develop a system for an ATM machine. A similar thing can be done for the parking slots as well, right? For different kind of vehicles, different kind of parking slots can be there, and one need to pass through each of the slots, each of the parking lots. And if you are in front of, if your vehicle is a smaller vehicle, and you are passing through the parking lot of a big vehicle, then you need to bypass it. The person will send you to the next parking lot, right? So you will visit the next parking lot, and you will see that no, this is also not for the small vehicles. So you will move to the next parking slot, which is for the smaller vehicles, and there you will park your car. So those are the kind of systems where you can use this, where you can take an example from the real life. Those are the examples from the real life where you can use the chain of responsibility pattern. So let's move towards the code. So I have written already some code, so I will just explain it quickly for you. So I have this ATM module class which contains two variables. One is request type and the other one is the next handler, right? ATM module asterisk next. And there is a constructor ATM module which takes the request type and it sets the request type, and then we have a function void set next slot in the public. It's a public method. Set next slot is the method, and after that we have run method, which is actually running the which will actually perform the task of dispensing the cash, depending on what kind of request you have placed and if that request is correct or not for your slot. Okay, so this one is setting your next handler, and this one is actually running the code, right? Actually running the logic. So this run function, you can see that this is a virtual function, so that each of the slot has its own implementation. Like here, in case of slot 500, I have created a class for slot 500, and in this slot 500, we have initialized this base class with 500, and then we have set the next to null. I mean, the next handler will be by default set to null, right? By default, next handler will be set to null. It will be set by the client application, right? That how he wants it to get done, how the chain will behave, right? And then we have the run function, which will be implemented for this slot 500 class. And here we are taking the currency, and if the currency matches with the request type, then we are going to display that yes, we are in the right slot, and cash will be dispensed. Okay, otherwise what will happen if currency is not the same which we want to dispense, which is available for this slot, then in that case it will go to the next slot to check there, and it will run the same logic there, right? So similarly it has been written for slot 1000 and slot 2000, right? Same code is there for every slot. And here what we are going to do, we are going to write like simple logic. ATM module asterisk p1 is equal to new slot 500, and we will write ATM module asterisk p2 is equal to new slot 1000, and then ATM module asterisk p3 is equal to new slot 2000. Okay, so we have set all the slots, and we need to create a chain of these slots. Okay, so p1 to set next slot is p2, and p2 to set next slot is p3. And what we are going to do, we are going to start from p1. We need to put something in the first slot, right? So we are putting a request of say 1000, right? We have placed a request of 1000, so let's see what will happen here. We are just placing a breakpoint here so that we can see how it works. Okay, so we are in the first slot where we have placed a request for 1000 rupees bill. So we will go to the next slot. Okay, just let me do one thing, because this is my great laptop where I need to just where I can't just use the F10 button. So just need to, okay, so let's go to the F11. So here I can see that it's the slot 500, because we have placed the request for dispensing the 1000 rupee to this slot, which is actually a 500 rupee slot. So what will happen? It will not be able to dispense it, because the request type is 500 and currency we have provided is 1000. So it will go to the else part, and it will display moving to the next slot. And now what is the next slot? The next slot is P1 to next is P2. So the next slot will be P2. So the run method of slot 1000, this is the slot P2 refers to the slot 1000. So the next run method that will be called will be from the slot 1000 class. Okay, so we will move into the class 1000. So here it will show you in right slot. Let me show you again, because I just clicked something else. I just pressed F10. So let me just run it again for you. So F5, we first go to the slot 500, and since 500 is not the right place to dispense the cash for 1000 rupees bill, so it will go to the 1000 rupee class, because the next handler is for 1000 rupees. So we will go to the 1000 rupees. So it's 1000, and request type is also 1000. We are setting the request type. If you see the code, then you can see that uh, each of the constructor, slot 500 constructor, is setting the request type, like what request type it is going to handle. So here we are passing the request type, and we are setting it to m underscore n request type. So this is already set, so that's why it knows that what is the request type already set and what kind of currency we want to dispense with. So we need to go to the next one, and here, since the currency is 1000 which we want to dispense, so it will display in right slot, and it will dispense the cash, and it will just return from here, and it will show in right slot. So first it will go to the moving to the next slot, because 500 slot was not the correct slot, and now we will put 2000. Then what will happen? It will first go to the P2, then it will go to P3, and in P3 it will be actually able to find out the correct slot. So we are in the 500 slot, it goes to the next slot, which is the 1000 rupee slot. But again, in slot 1000, it is not the correct slot, so it will go to the next slot, which is the 2000 rupee slot, and this is the final slot. Okay, so this way it works. So the cash has been dispensed, right? So this is the way it works, and let's do one more test case, which is for 500. So here we can go again to the 500 slot, and which is the correct slot, so we will be able to get the cash right away in the first slot itself, in right slot. So first slot was the right slot for it. What happens if you put something wrong, like if you put 3000, right? So in that case, what should happen? If all has been done, then what will happen? It will go to the next, right? So for that, what we need to do, we need to first check that how it will behave, right? First, let's check how it will behave. So we went to the run method of 500, and then we went to the run method of 1000. Then we are going to the run method of 2000. Here also it's like we have the run method for the next one, but we don't have any next. So what we will do, we will just go to the next one, and it will crash because the next was null, because we have not set the next for the P3, right? If we have not set the next for the P3, then what we need to do, we need to check in every else part that if P next is equal to null, then what will happen? It will just return invalid. I think it's invalid only. Yeah, invalid request. So the same piece of code I need to just add everywhere, right? So that if anyone sets the chain in some other way, then in that case as well, this piece of code will be true for everyone, right? So now it will give you the invalid request. In fact, I should have written some message. So here I can write some message like, you can put something like, go to hell. So you can just copy it, and in everywhere you can place it, go to hell. Why you are putting this amount of money which I can't dispense? Okay, it cannot dispense 3000 or 4000, so it will just tell you go to hell. So let's see the output. Okay, so it's moving to next slot, and then go to hell. So this is the way you can write your code, and this is the way you can return if your system was able to handle some request or not. Alright, so this was all about for today's design pattern, which was the chain of responsibility pattern. So in the next video, we'll meet soon. So till then, have a nice day and bye bye.